In this video, let's see the topic on bearing capacity of the soil. First of all, myself, B. Chalapriya, Assistant Professor Civil, Rogini College of Engineering and Technology, Palkulam. So, first, what is mean by bearing capacity? Bearing capacity is nothing but strength of foundation soil to hold the load from the superstructure without undergoing any shear failure or existing settlement. So that is capacity of soil to bear the load from the superstructure and without causes any settlement or shear failure, then it is called as bearing capacity. There are three mode of failures: general shear failure, local shear failure and plunging shear failure. And it depends upon the shear strength of soil as well as shape, size and type of foundations. So some basic definitions are: first one is ultimate bearing capacity or gross bearing capacity. It is defined as bearing capacity inclusive of pressure exerted by the weight of the soil, that is surcharge. It is the least gross pressure which will cause shear failure of the supporting immediately below the footing. Next one is net ultimate bearing capacity. Net ultimate bearing capacity means maximum load per unit area. In excess of surcharge pressure, this foundation soil can withstand without causing any shear failure of the foundation. So, a net ultimate bearing capacity, it is denoted as QNU and it is rewritten as QU minus sigma bar. Sigma bar is nothing but gamma into D. Next one is safe bearing capacity. Safe bearing capacity means maximum load per unit area while the foundation carries safely without any risk of shear failure or with factor of safety against shear failure. So, safe bearing capacity is calculated as ultimate bearing capacity divided by factor of safety. So, below that, safe net bearing capacity QN is denoted as net ultimate bearing capacity is divided by factor of safety is called as safe net bearing capacity. The factor of safety is 3. Next one is gross safe bearing capacity, that is QS. It is nothing but ratio of ultimate bearing capacity divided by factor of safety. It will give the gross bearing capacity, that is QS equal to QU divided by F. Next one is allowable bearing pressure. Allowable bearing pressure means it is a maximum soil pressure without any shear failure or settlement failure occur. Next one is net safe settlement pressure. Net safe settlement pressure is nothing but soil can carry without any exceeding the allowable settlement. Net allowable bearing pressure is denoted as QNA. It is used for design of foundation. This is equal to net safe bearing capacity. And let's see the method of improving the bearing capacity of soil. So, by increasing the depth of foundation or draining the subsoil water, such as groundwater. Next one, by compacting the soil or replacing the loose soils. By confining the soil or preventing the spreading of lateral movement, either by earthquake or any portion of any sewer line, etc., or by increasing the width of the foundation, or by hardening the soil by grouting or any stabilization method, or solidifying the ground by any chemical process, or compacted with certain chemicals such as calcium chloride, etc. Next, what are the factors influencing bearing capacity of soil? First one, soil strength, foundation weight, foundation depth, soil weight and surcharge, spacing between foundation, earthquake and dynamic motion, and frost action. subsurface walls, expansion and collapsible soils, potential heavy soil reinforcement, soil erosion and seepage. These are the factors influencing in bearing capacity of soil. Next one is type of shear failure of foundation soil. There are three types of failure: general shear failure, local shear failure and punching shear failure. The following figures are given below. So, first one is general shear failure. General shear failure is seen in dense and stiff soil, and it is some of the characters, that is failure is well defined and distinct failure surface develop between the edge of the footing and the ground surface, and the shear mass adjacent footing is visible, and failure is accompanied by tilting of footing, and the failure is sudden with the prominence of peak in curve. Next, in general shear failure, the state of plastic equilibrium is reached initially and spread gradually downwards and outwards. General shear failure accompanies a low strain less than 5% in soil, and large N is greater than 30, high relative density. Next one is local shear failure. Local shear failure seen in relatively loose and soft soil, and some of the characters are here. The partial development of plastic equilibrium is observed. Next, the failure is not sudden and there is no tilting of footing. The failure surface does not reach the ground surface and slightly bulging around the footing only, and the failure surface is not well defined, and the local shear failure is accompanied by strain is 10 to 20% in soil with considerable low, and low N is less than or 5, having low relative density. Next, third one is punching shear failure. Punching shear failure is seen in loose and soft soil at deeper elevations. The following characters are: this type of failure occur in soil of high compressibility and failure pattern is not observed. Also, bulging of soil around the footing is absent. Failure is characterized by only very large settlement, and continuous settlement with no increase of pay is observed in P delta curve. So in this video we have seen about the bearing capacity of soil, some of the factors which affect the bearing capacity of soil, and how to improve the bearing capacity of soil, and some definition, and finally the causes of shear failure, that is general shear failure, local shear failure and pinching shear failures are discussed in this video. Thank you.